Hello, this is Mr. Collier, and today we're doing quadratic modeling. Okay, in the first example, actually we have a starter that's not really related to quadratic modeling. It's just solving by graphing. Actually, let's change this number to 4, otherwise there's actually no solution. So let's change this to a 4. And then to solve by graphing, we're going to do this one with the TID4. Actually, we'll do this one with the HP prime and do this one with the TID4. So with the TI-84, we will go to y equals and press clear, and we'll type in the whole left-hand side as a function. So we have x plus 1 plus, now to get a fraction we do alpha y equals, enter, 1 over x. So that's the left-hand side of this equation. Now we're just going to graph the function y equals 4. That will give us two graphs. I will check window first to see if we have a normal window. I usually set this to -10 to 10, and on the y-axis -10 to +10. Okay, unless we can't see it, then we have to make the ranges bigger. So let's graph it and see if we can see everything. So that's the left-hand side here, and the y equals 4 is just a horizontal line. So you see there's two points of intersection. So that means there's two solutions to the equation. Okay, so we need to find those 2 points of intersection. So we go second, calc, and number 5 is intersect. And we'll just move over to where a point of intersection is. We press enter, 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 and then we get one point of intersection is that one right there. So we can show our work. We can draw a sketch. Okay, and then we have, so this curve looks like this, and this curve looks like this, and there we have the straight line going across. So here's our two points of intersection. This one right here, let's label it, is 0.382, comma 4. And then the other one, we have to do the same procedure. Second, calc, number 5. And then make sure we're over here next to this point of intersection. Press enter, enter, enter. That's 2.62. 2.62, comma 4. Okay, but the question only has x in it, right? Solve the equation, find out what x is. So actually our answer is x equals 0.382 or x equals 2.62. There's no y in our answer, it's just the x values that we're looking at. Okay, next we're going to do solve this equation using the HP prime. So I think I already have it graphed here. So we go to apps, and we go to function, and you can type in the function here. Make sure you use this x value right here on this button. Okay, so you just type in the function in F1 and F2. That will graph. Oh, this is a different function, so I do have to retype it. Sorry, that's not the same function. So we go to Shift Clear, enter, and it'll clear everything. So on the left-hand side, we just have it's a straight line. Y equals. Oh, so that should be negative 2x plus 1, and then we'll graph this one here as a quadratic or a parabola. So that's 0.4x squared minus 5.92x plus 25. Okay, so we got them both in there. We can press plot now, and then we can see them. You can move it around, you can zoom in and out with your fingers if you're using a handheld calculator. You can even go to shift plot and change it manually. But we can see 2 points of intersection, so let's go ahead and sketch the graph first. It sort of looks like this. Now, sketching the graph for this type of question is not too important to be accurate, just to show the basic shape and the fact that there's 2 points of intersection. Okay, so let's find those 2 points. So we go to Menu, Function, Intersection is number 5. Press enter. So I get this one on the left, 4.27. 4.27. And this one on the right, I'm going to click over here and then do the same procedure. Function, intersection, press enter, and that is negative 14.1 and 29.1. Okay, so the answer is x is negative 14.1 or 4.27, right? If you do this with a TID4, then you need to go to Window and make your window bigger, or you won't be able to see the points of intersection. Okay, next we are going to do some modeling. So that means we have some real-life data that's probably quadratic, and we're going to fit a quadratic curve to model the situation. So here we have a pumpkin tossing contest is held each year, where people compete to see whose catapult will send pumpkins the farthest. Sounds like fun. One catapult launches pumpkins from 25 feet. Okay. The table shows the horizontal distances traveled when they launch at different angles. Okay, so if you launch at different angles, I mean the pumpkin goes like this or it goes like that, depending on the angle, right? So we want to model that. So one way we can do that is actually I'm going to show you on an online graphing program called Desmos first. So I'm going to type in these values. We got these numbers right here. I'm going to go to here and we'll click and go to tables. So make sure you're on Desmos and then go to make a table. And then you can type in the x values here. I think we have 40, 50, 60, and I think it goes up to 70. Let's delete that, 70. And then the y values are 372, 462, 509, 501, and you're going to be using Desmos for your criterion CD coming up, so make sure you, 323. So make sure you know how to use Desmos and you practice using Desmos. Now I've got the points in there. You can't see anything right now because these points are quite large. What you can do is you can move like this, but you can go to this wrench thing up here and you can change the x-axis to go from maybe 0 to 80. Oops. And you can change the y-axis to go from, we've got numbers going from the 300s to the 500s. So I'll go 300 to 600. Okay, now we can see all the points, right? And it looks fairly like a parabola shape. So we're going to do this by hand first, try to fit the curve. And one way to do that, I mean, if you had the x-intercepts, maybe you can use Intercept Form. I can see about where the vertex would be, so I'm going to use Vertex Form. Now, where's the vertex going to be? I think it's not going to be this point right here. It looks like it would be right about here somewhere. Maybe right there. Maybe that point right there. What is that point? So that point would be, looks like the y value would be 520. Right, so let's write that. Y value would be 520. All right, so the vertex, the y value would be 520 about. The x value over here is going to be 2 blocks over from there, so that's 44. Okay, 44. So let's say the 44, 520 is our best bet for the vertex. And so we can write in vertex form, y equals, or you can even use these d and a if you want to, instead of x and y, right? Or you could just say y equals a. We don't know the a value. We're going to find that algebraically. X minus 44 squared plus 520. The a value we can find by substituting in another point. So probably one further away from the vertex, like this one. If we want it to, if we plug in this point here, our parabola will definitely, our equation will definitely make the parabola go through that point. Or we could use this point. Let's use this one right here. That's the one 7323. So we can sub in 7323, and we'll get 323 equals a times 70 minus 44 squared plus 520. So we're going to subtract 520 from both sides. Equals a times, this is 26 squared. Okay, so yeah, we're going to subtract that. We get, actually, let's write it out like this. 323 minus 520 equals a times 26 squared. So a equals 323 minus 520 over 26 squared, and we can just go and calculate that on our calculator. So it's pretty actually easy on the HP prime. So I'm going to show it on T84 again. So we go quit, we go to alpha, y equals, and we can type in 323 minus 520 divided by 26 squared equals, now that's a fraction. I guess we could leave it as a fraction. Let's see what it looks like as a decimal. Go to math, decimal here. Yeah, often with modeling we use a decimal instead. Okay, because it is just an estimate. We don't need to be exact. So a is about negative 0.291. Okay, so our final answer is it's negative 0.291 times x minus 44 squared plus 520. Okay, so if I go now to Desmos here, I can type that in and let's see what happens. Y equals negative 0.291 and x minus 44 squared and plus 323. Okay, what happened there? Oh, it's plus 520. Sorry, 520 is at the vertex. There we go. So you see it exactly goes through this point right here, and it sort of fits the point. It goes right through this point right here, and some of the points are just a little bit off, right? So in a criterion CD test, you could talk about the distance from the point to the curve. You could even add up all the distances from the point to the curve, and that gives you some sense of the error, right? So let me show you another way we could do it. So let me turn that off for a second. You could use what we call a slider. So y equals, I'm going to just type in y equals a times x minus 44. Actually, we can even make a slider for these variables too. So I'm just going to put them all in terms of a, h, and k, and we can click all on add slider. And then you can change these values, right? So we know h is about 44, so let's go stick it to 44. Actually, you need to change the range here. We need to go up to maybe 50. It's going to be between maybe 40 and 50. Change the step size to be a smaller number, like 0.1. And for the k value, we said the k value was 520. So let's go between like 500 and 540, and then we can play around with it. Change that to 0.1. Now our a value before, we said it was negative 0.291. So let's go from negative 0.28 to negative 0.3 and make the step size small, and then I'll show you what we can do. Now we have this parabola. We want to move it up a bit. Actually, let's move this to 42. Let's change it to our model. We said that was 42 before, or did we say 44? I think it was 44. Right, was it 44? Yes, it was 44. Okay, and this was 520. 520. The a value was 2. Did I make a mistake here? Oh yeah. Negative 0.3 is actually smaller than 0.28, so we've got to put the 0.3 here and the 0.28 here. Now that is done. How do I, maybe I just press enter here? Okay. So we had 0.291. That's our model, right? That's the same as we had before. We can verify that by just clicking right here. Yeah, they're actually the same. So I can make this slightly wider by doing this, you see? And maybe I want to move it over to the left a little bit. There you go. So we can just change the H value. It moves it over to the left a little bit. That looks pretty nice. Maybe I'll make it a bit wider by doing that. So now you can see you can play around with the sliders and you can make a better fit, right? This looks much closer to the points. That looks pretty good except for that last point on the left. Maybe I could change this one. Anyway, you can change around. You can calculate the distances between the points and the curve and figure out if you have less error than our original model, right? And let me show you another way we can do it. We can do this on your calculator. I'll show it with the HP prime or the TID4 first. We can go to y equals, let me clear that. We can go to statistics, edit, and then we can type in the numbers here. I'm going to go up to L2 and press clear. I'm going to go over to L1, press clear, enter, and we can type in 20, 30, 40, 50, 60, 70. And then we can type in the other numbers, 372, 462, 509, 501, 437, 323. Okay, and then we can go to Stat, Calc, and we have something down here called Quadratic Regression. So click 5. Make sure that says L1 and L2. Okay, and I'll calculate, and then we get this quadratic. So this means this function actually minimizes the distance between the curve and the points. Okay, it minimizes the average distance between the curve and the points. So it is technically the best model. So if we go to look at that TID4, so there we have. This is going to be y equals negative 0.261 x squared plus 22.6x plus 23. So you see our a value is a little bit different, it's a little bit off, right? And you could probably change this to vertex form, or you can change this one to standard form, and you can compare the model you calculated with the best fitting model generated by the calculator. Now I will show how to do it with the HP prime. Okay, so next with the HP prime, you go to apps, and you need to go to actually two variable statistics. Go to statistics 2 variable. Press enter. You need to type everything in here. If there's something already in there, press shift clear. So type in all the data here. Then we go to symbol. This is probably already set on linear. Make sure this says C1 and C2, where you have all your data written down. Make sure this says quadratic, and then we'll show quadratic, general quadratic here. Maybe you click fit. No, never mind. I think fit means you can actually see it or something. What you need is, what you need is the equation, which is right there. If you don't see it, just escape, then go back. Eventually it pops up there. Okay, so that is the same one that we got right here with the TID4, because it's calculated the exact same way. It is mathematically the model which is closest to those points. Yeah. Okay. Yeah. All right. So let's move on to the next one. Let's get a best quadratic equation to fit this data, and then use your model to interpolate the number of TVs in 1982. So this is years since 1970. 1982 is like when the years is 12. So we want to figure out what that is. So let's do that by modeling, and we could do that on our calculator. So you can go and type in all this data. All right, enter. So I'll need to go up here and clear. Don't press delete or it'll delete the whole list. Clear. And then we have the numbers 0, 5, 10, 15, 20, 25, 30. Okay, and then we have 21, 47, 63, 78, 90, 94, 101. Okay, got them all in there. Make sure they're all correct or your whole model will be wrong. And then we go stat, calc, quadratic regression, number 5. And enter, enter. Make sure that says L1, L2. Make sure there's nothing in frequency list. And there you go. You got the equation. Okay, so this is y equals negative 0.0767 because last digit will round up. X. We don't need any more digits than this because it's all an estimation anyway. So that's 4.88. X, this should be an x squared, plus 22.3. So that's our model. And then to figure out how many TVs there are in 1982, you just plug in 12, okay, plus 4.88 times 12 plus 22.3. Okay, so we can do that on the calculator. Just do negative 0.0767 times 12 squared plus 4.88 times 12 plus 22.3. Okay, and we get 69.8, which is approximately, I guess I'll say 70. It's about, because it's an estimation, we can't really be too accurate with it. So about 70 million TVs had televisions in the year 1982. Use your model to extrapolate to 2008. Okay, 2008 would be 38. And let me address this one right away. Does your answer make sense? Well, extrapolating is always dangerous. The further you go away from the range of your data values, the less accurate it's going to be. So we can do the same thing and just plug in 12, but it's not going to be as accurate as when you're interpolating. Alright, let's move on to this next one. I'll let you do that yourself. Next one here, we have a tower bridge, suspension bridge, and we have the data here. The maximum sag in the middle is 20. So that means this distance is 20. Okay, which means that this vertex is going to be halfway across, so that's 30, and 30 is the y value as well because this is 50, right? So this is 50 minus 20 is 30. So we know the vertex, so we can start with vertex form. Actually, part A just asked you for the vertex, so that's 30, 30. Find the equation of the parabola, so it's basically find the a value because we know the vertex. To get the a value, we can plug in another point. Like, for example, you can plug in this point, which is 0, 50. Or you can plug in this one here, which is 60, 50. Okay, this one, either one of them will be give you the same answer. So let's use this one. So 50 equals a times 60 minus 30 squared plus 30. So that means 20 equals a times 30 squared. So 20 equals 900a. A equals 20 over 900, which equals 2 over 90, which equals 1 over 45. So we got our a value. So our equation is y equals 1 over 45 times x minus the vertex is 30 squared plus 30 is our model. How high is the cable directly above x given that xr is 10? So if this distance is 10, then x is over at 50, right? So the point x is going to be 50 comma 0. So we can substitute that into the equation. Okay, so 0, actually we just plug in, this equation is just based on, oh sorry, we're looking for this distance, right? So the x value is 50 here, so we just plug in 50 into this equation and we find the y value at that point. Okay, so y equals 1 out of 45 times 50 minus 30 squared plus 30. So we have y equals 1 over 45 times 20 squared plus 30. So let's do that on the calculator. So we have 1 divided by 45 times 20 squared plus 30 equals about 38.9. Okay, so y equals about 38.9. Okay, next I'm going to go over a couple questions from your homework so you know how to do it. So let's take a look at this one. The following quadratic equations are in vertex form. Write each of them in standard form. So standard form looks like this: ax squared plus bx plus c. So basically we need to just expand this and simplify. So x minus 1 squared is going to be x squared minus 2x plus 1 plus 9, which equals negative 2x squared plus 4x minus 2 plus 9, which equals negative 2x squared plus 4x plus, that's a 9, so that's going to be 7. So that's it. That's in standard form. Next, we have vertex form. We already know the a value. Write it in standard form. Given that the turning point of the graph, that means basically the vertex. Okay, that's the vertex. So actually just plug it in and write it in standard form. So it's the same as, it's basically the same as number 1 that we did. Okay, so you expand that and simplify and you have it in standard form. Okay, next type of question you have in your homework. A parabola has an equation of this form. Find the equation if the x-intercepts are these. So we can start with factored form, also called intercept form. Factored form looks like this. Y equals a times x minus one of the roots. We'll call it alpha. Maybe we'll call it p. Okay, if p and q are the x-intercepts, then this is factored form or x-intercept form, right? In this case, the a value is 1. That's going to be the same in all three forms, so we don't have to worry about a. So you just take y equals x minus 7, x minus negative 1, and you expand it and you get standard form. Okay, so we have y equals, this is like a plus 1. So y equals x squared plus x minus 7x minus 1. So it is x squared minus 6x minus 1 in standard form. Okay, lastly, parabola has the equation of this form. What is the equation if the x-intercepts are negative 4 and 7 and the y-intercept is negative 25? So in this case, we don't know the a value. So when we look at the x-intercepts in factored form, we have a times x minus negative 4 times x minus 7. So that's going to be a times x plus 4, x minus 7. And we have, we'll have to expand it. Actually, we don't have to expand it if we don't want to yet. Okay, right now we can sub in 0, negative 25. Okay, so we get negative 25 equals a times 0 plus 4 times 0 minus 7. Negative 25 equals a times, that's 4 times negative 7 is negative 28. So a equals basically 25 over 28. Okay, so that's it. We need the equation. What's the equation? I guess we need the standard form. So we need to actually expand this now. This is going to be y equals 25 out of 28 times x squared minus 7x plus 4x minus 28. So y equals 25 out of 28 times x squared minus 3x minus 28. So y equals 25 out of 28 x squared times 3. So that's going to be 75 out of 28x. And here, last one, the 28's cancelled, so this is going to be minus 25, which makes sense because our y-intercept is negative 25, and that equals this value in standard form.